So the topic for today is about the Amazon EventBridge. This topic is mainly around the serverless. I assume that all of you are somewhat familiar with the word serverless itself. It's gaining a lot of popularity, a lot of traction, similar to how the Docker and the Kubernetes are. I'll keep my video enabled as long as everything is good. If I see any speed issues, I'll disable the video. But I like to keep the video on. So about me, like Manoj mentioned, I currently have 12 AWS certifications. I am also AWS Serverless Hero, more of a kind of a recognition than a designation, but I'm a Serverless Hero. I am also recently AWS certification SME. So when I started preparing for the certification, I gave the exams, and now I prepare the questions which eventually will make it into the AWS certification exams one day. I also run the user group in Surat, my city. And I also own and run a cloud consulting and a development firm, App Gambit. We are also AWS consulting partner here in India. So that's about me. To start with the agenda, this topic is mainly around the serverless and the serverless ecosystem, and the one of the recent, I will not say very new because it's almost just little over a year old. We are going to talk and explore more about the Amazon EventBridge, which is a serverless service, how it works, and we'll see a few demo, and again we'll see the key takeaways about the EventBridge. So I'll start with a very basic and a fundamental thing. So serverless and events. So you must have heard even Manoj doing all of these sessions on the YouTube and on the serverless. So when we talk about serverless, everything starts with some kind of a trigger. You have a trigger which actually then moves to the serverless, one of the service part. In most cases, it leads to Lambda, one of the most popular serverless compute service. All the events coming from the different sources, you can attach with the Lambda. So serverless fundamentally, it is everything about events, how the events are generated, how they travel from one service to another service, and how they end up to one of the many services which can consume these events and work on it, either via the compute, either via the communications, either store it into the DynamoDB or store it into the S3 and stuff like that. So, but ultimately, it is the events that are passed from one service to another service and gets processed in the middle. So the typical structure is, we are going to take a very simple example application. So this is my example applications which I have taken from a reference implementation. Let me know if I'm not audible. I'm going to keep an eye on the messages, but just to make sure that I'm audible enough. So this is an example reference applications. You see different components. Nowadays, whenever you are starting any service, microservice architecture is a very kind of, it's assumed that every thing will be in a microservice way. This is also, the entire application is structured into different components. We have the users who do the login, logout, products, get the products, search the products, orders, create the orders, and that integrates with the downstream services like the warehouse, delivery, payment processing, and again indicating those notifications to user directly. Now, if I need to design this via the serverless, a typical structure looks like that. We have the individual services, and there is some gateway point. Either we use the API gateway, either we use the SQS, either we use the SNS, but there is some kind of a gateway service through which I can actually pass the message. That's a very, very simple notion, that if I need to build this via the serverless, and ultimately if I have some Lambda which actually is going to process the event and run the code, I need to put the Lambda behind something. Either I can call the Lambda directly, but in most of the cases, I will have some kind of a scalable front end, API gateway, SQS, SNS, and that leads to the processing of the event via the Lambda. So this actually, if I need to implement all of this kind of creates a lot of communication channels. I have the multiple API gateway, I may have the multiple topics to listen to, may have the multiple queues to listen on, and then ultimately there is, even though it looks like a bunch of microservices, but they are very tightly integrated, because I know that where I need to post, and I have the listeners also configured on that. So eventually, over the period of time, this will again look like a very large monolith in itself. So if I want to re-implement this via the this new service called EventBridge, which is nothing but a serverless event bus, which is fully managed, fully serverless communication service, where there is a concept called event bus. So you create the event bus, we'll see in the later slides, you create event buses and you listen to individual buses based on the rules and the configurations that you have created, and ultimately you redirect the events passing from those buses to your targets. So this is part of the reference implementation, where it is converted from the SNS SQS to EventBridge. So EventBridge is hosting the multiple buses that we'll see in the later slides. But again, the central point here is, instead of individual SQS, SNS, or API gateways, it is now the central point of communication has become the EventBridge. And then all the individual services are listening to the events relevant to their requirement, and then acting upon that. Now, one thing before we go into that, the concept of, many people find it very difficult to differentiate what is an event and what is a command. So when I make an API call, in most of the cases, that API call, even though it is using the API gateway and using the Lambda, which makes it fully serverless, but my call will be synchronous. So the integration between the API gateway and the Lambda can be synchronous, asynchronous as well, but let's assume it is synchronous. In that case, I'm sending a command to API gateway that I want this to happen. Okay, I want this to do, either I want to get something, or I want to update something, and I want the response back. Event is something that has happened, and we are consuming the event for the post-processing. That is the, even in many of the talks from the AWS and the AWS services related, you will see this notion of that something has happened and the other services needs to act on top of that, and then the rest of the flow goes afterwards. It is not that the client will keep on watching. They will listen to the progress, or they will listen to the other updates after that, but they will actually stop the processing from that point and let the event actually follow up with the standard natural route that the overall system has designated. So this is again a simple use case where I've taken the similar services, order placed. If I am completely dependent onto the payment services via the synchronous calls, then what happens if the payment service goes down, or there are the throttling, the limits are hit, or some other issues with the payment service? So in that case, everything comes back to the order service to maintain. So we have to maintain the retries, the backups, and the other error handling. So these are the common grounds on which we go into the concept of asynchronous event processing, and that leads to our next part, where we will start with the EventBridge. So in AWS, there are multiple options to do the communications, passing the event from one place to another place. Amazon Connexus, which is very popular service to, again, fully managed serverless service to actually ingest large amount of data, falls into the streaming event category. SQS, one of the first service into AWS that is more to do the directed event transmission, one source or set of source to like one consumer process the event one at a time. SNS, again, extremely popular. It's the default service integrated with CloudWatch Events. So every time you want to send out any sort of alerts or notifications, the SNS comes first into mind. SNS and EventBridge has a very a lot of overlapping, and most people who actually try both, they have this question that when should I use the SNS or when should I use the EventBridge, which I will take care in the later slides. So that is mainly for the PubSub. SNS is basically a PubSub, publisher and subscriber. You can have the large amount of subscribers. The common example is that during the early days when the push notification became very popular and AWS integrated that, so all the push notification endpoints that is created, that is nothing but a SNS subscriber. So you can imagine that if my application is very popular and I have hundreds, thousands, millions of users, there is an endpoint for each one of those in the SNS. And EventBridge is the newer service launched just last year, right before reInvent. That is meant to kind of create a serverless, fully managed event bus. Now, the concept of event bus is not new. It's very popular. It's there in the Java ecosystem for I think a couple of decades back. So, event bus is basically mainly used to illustrate the communication between handful of services or components, but handful of source and destination. So that's the basic definition. Now we are going to explore more about the EventBridge. So EventBridge is not an extremely new service. As such, it is created on top of the CloudWatch events. Right now also you can use, if you go to the CloudWatch events, you can actually create the rules. If you go to the EventBridge, you will see the same rules there as well. That's why it is called nothing but an extension, or the extension of the service created on top of CloudWatch events. So it's same as CloudWatch events plus more features. It uses the same API and the underlying infrastructure. Existing CloudWatch events, if you have created any events, or if you have any watch or any alerts or notification configured inside the CloudWatch, you will see the same rules, same thing in the EventBridge as well. You can continue using CloudWatch events. You can use both in parallel as well. Great. This is the last page I will take later. It's a new addition, very recently added, just last week or 10 days back. So this is if you go to the CloudWatch events, this is the first thing that you will see. The CloudWatch event is now Amazon EventBridge. You can continue using the CloudWatch events, but if you want, please shift over to the EventBridge. So looking at the EventBridge, every service has some core components. So what makes the EventBridge? What are the core components of the EventBridge? So at the very core, the EventBridge has event bus. That is the medium on which the events will be consumed and will pass on. The actual event, that is nothing but the payload, which will be JSON payload. The rules which actually act on top of the event bus, and they actually help in the filtering and routing, which is the very popular part of the EventBridge itself. Then the source and the target. So you have some source predefined set of services, and you have the targets, which is the predefined target services to which you can route your events. And event schema, which is again not a very core component of the EventBridge, but I still feel that the way they have created one feature, event schema plays a central role in that. So how it all looks together. So if you open the EventBridge page on the AWS, this is how it looks. You have a very nice diagram where you have on the left hand side, you have the services, AWS services. Again, if I talk in brief, so there are these are the source AWS services. You can have the custom application as a source, and you have the SaaS application. That's where the concept of enterprise event driven architecture or enterprise event bus comes in. So they allow not just the AWS and the custom application as a source, they allow there are SaaS applications through which you can actually consume the events. Once the event comes inside the EventBridge, then you have the different bus, and you have the rules attached with that, which helps in the routing and filtering. And then on the right hand side, you have a set of target services. Once your event has done the filtering and other processing modification, then it will route to those target services. Yes. So starting with the event bus, the first thing is you need to have a bus. You need to know where exactly the event will come. So that is the place where the event bus will come into the picture. That actually helps in the routing and filtering as well. By default, if you have never opened EventBridge, if you open it first time, you will see one bus already there. That's called default. That is meant for that particular account. So you have a default event bus for that account. You can have partner event bus as well. So SaaS partners, there are 34, 35 SaaS partners currently. So you can immediately start consuming events from those partners. And then you can have custom bus as well. So I have a custom application and I want to actually emit events which will be used by other applications. In the earlier example, as we saw, we have the different microservices, and I want to actually route the event of something happened, like a user has placed the order, a user has signed up. So all those kind of events, if I want to consume, I can use the custom event bus to actually relay the events for my custom application. So this defines the event bus into three different categories. One is a default or AWS services, meant for AWS services. Second is meant for the SaaS partners. Again, this is only for the registered SaaS partners. You cannot have any SaaS partner of your choice. The partner has to register with AWS, which is a very simple process. There are 34 partners available right now. Fairly good compared to what when they started. And custom bus, you can always create your own bus for your internal, your application specific communication. The next is the events, the JSON payload, which is being transmitted from one place to another place. So relating to the event bus, you can have the SaaS services posting their own updates. One of the demo example that I'm going to take is the MongoDB Atlas. So my MongoDB is running outside the AWS. It is running in the Atlas, their own infrastructure. And how will I actually send or emit the events from the MongoDB to AWS EventBridge without actually doing anything, without creating any infrastructure? Then you have the AWS services, very simple one. All the AWS services emit events, and we know that the ground source for all those events are CloudTrail. So it actually supports 95 or so services. But again, if your service, if the service which you are targeting for the source, if it is not part of the registered source, you can actually always fall back to the CloudTrail and you can still listen to those events. Custom events, I will show a demo of those as well. And because this is an extension of CloudWatch Events, which has the fixed and the scheduled one, this also has a scheduled event. So you can actually run the cron job and invoke those events as well. So these are the four categories of events that can actually relay from the EventBridge buses. Now we'll look at the simple structure. So the event, similar, if you have already done some work with the SQS or SNS, all the messages that are being transferred, they have some kind of an envelope structure. So this is the full body of the event that is being passed through the event bus. And if you do not do anything, your target will receive this. So there are some high level fields: version, ID, detail type, source, account, time, region, resources, and details. So these are the high level fields. For the full payload that is event specific, whether it's EC2, this example, if there is an EC2, so the actual event payload will be part of the detail. So it will be, a detail is another JSON. All others are high level fields. Some of those are pre-filled and having the fixed values, like the version is fixed 0, ID is auto-generated, detail type and source depends on from where the event has been generated, time is auto-added, and the region, from which region it has generated, and the resource, that which resource has kind of generated the event. So this is the high level structure of the event. I'll actually show how it looks inside the schema registry as well. Then now we have the bus. Now we know that what the event looks like. The next thing is the rule. So we know that we have a bus, we have created a bus, but how do we make sure that where I need to transmit, where do I need to integrate this event? So that's the place where the rules come into the picture. So you can actually have this kind of a configuration attached to event bus, where you can specify that where exactly, what exactly should I take in. So that is the filtering part. You can actually do very granular filtering. So if you listen to CloudTrail, so CloudTrail will emit hundreds of messages, but you are only interested into certain messages out of those. So either you can write down the lambda, custom lambda, to filter out those, ignore what you don't want, and then relay the other things. Or with the rules, you can actually just define that these are the rules that you are, these are the messages that you are interested in, and everything else will be ignored. So rules actually plays the flexibility part. SNS also has the messaging, message filtering, but it actually only applies to certain attributes, not to the full body. But rules, EventBridge rules, can apply to the full body. So you can actually also do the filtering on the high level fields, not just the body part, but even the high level fields. So that's why it's very powerful and very flexible. Rules also has the other properties to actually transform. So you can do the transformation and then point to your target. Each rule can actually point to up to 5 targets. So you can actually do the fan out, which SNS can also do, although SNS fan out will be much larger in the size. But here EventBridge rule has only capacity of 5 targets, and you can do the filtering as well as the transformation without doing any compute layer in place. So this is how the event pattern, that is the filtering part, looks like. On the left hand side, you have an event with high level fields, and on the right hand side, I have actually highlighted in red that these I'm putting a filters. So although it emits all the events, I'm only interested in listening the AWS.EC2. So events which are generated from the AWS service, it starts with AWS dot and then the service name. So in our case, it is AWS.EC2. And the detail type is basically nothing but a text string which AWS attached. What exactly is the state? What exactly is the type of the event? And then inside the detail, we have the state terminated. So I'm only listening for the EC2 being terminated events on this particular rule. So it's a very simple configuration through which I can listen to what I really want and ignore everything else. It has an array-like structure, so I can actually put multiple values to grab a bunch of events and not just one-on-one. Now that is one-on-one, so it is exactly matching the string, but it is not limited to that. And because the EventBridge is considered to be a much powerful, and in the future also they keep on adding more features, they have actually added the additional filtering kind of patterns as well. So you can do based on the prefix. So time which is a fixed pre-defined value. So you can actually prefix on that as well. State anything but, you can do the negation as well here. Numeric greater, less than, and anything but. So you can keep you want to actually eliminate certain values and accept everything else. So these kind of complex patterns also you can actually put inside the event pattern and filter accordingly. So it is not just string equalizations, it supports many other forms as well. Transforming the event, JSON payload comes in and you want to transform it before you send out. So you can actually do the transform via the simple templates part. I'll show that during the demo as well. But this is a place where you can customize. So the rule can do the filtering as well as the customization before actually it passes on the message to the target. So this is the transformation, how it looks like. We have the input path. Familiar with the templating or VTL, you will recognize the way it is written. So here the input part says that I'm looking for these two variables. So I have created the variables instance and state from the incoming input type. So $.detail. So detail is part of my message, and then .instance. So I'm actually extracting the instance and state, and I'm creating two variables out of it, and then into the template I am converting those variables into a different event. It could be a string as well, it could be JSON as well. Some services do not accept strings, like CloudWatch will not accept string template, so you have to pass a JSON. Lambda will accept string as well as JSON, so both this template will work fine with Lambda. We'll see that in demo as well. So next comes, now we have the bus, now we have the rules. We know what exactly that we want to take in, we know if we want to transfer or not. So what are the sources and the targets available? So as I mentioned, so 90 plus services are available as source, 34 AWS partners are available. These are the registered partners. These are available as a source, and there are 7 target services. So once you receive the event, once you do the filtering, once you do the transformation, if you want to, you can use any of this as a target. And as I mentioned, each rule can have up to 5 targets, so you can do the fan out as well. Compared to SNS, which has much lower target service, I do not remember the exact number, but it has lower target services. And EventBridge has the higher number of target services compared to SNS. So this is the current integration options are available. Now, the next thing is we saw that we are actually transmitting the events from one place to another place. Now, because it is considered to be an enterprise event bus and it has the integration of a lot of partners as well, whenever we do any sort of integration, the first thing, any integration with third-party services, the first thing is we go to their documentation site and we try to find out that what exactly their payload looks like. Whether it's the direct API integration, then we look at the response which they are sending. Well, if it is a webhook, then we look at what exactly they'll be passing us, so that we can code our logic accordingly. Without knowing the structure of the event, it will be hard for us to figure it out, or we have to do the trial and error, that what all information that we need to either send or we need to either receive and process. So schema is the thing that which EventBridge has added as a feature. So what it does is, if there are so many events are being passed on, and again, an event bus can have different type of events as well, because I have the flexibility of creating different rules. I can accommodate different kind of events into a single bus. So I can have all of my application related events passing through a single event bus, and then I'm writing different rules to filter out and send it to different targets. Now in that case, if I know that I have only just a few events and close team, then it is very easy to understand that what exactly our schema will look like. But if it is a very large application having dozens of modules and all are transmitting the events, it's very difficult to identify, or we need to put this event documentation at a separate place, just so that everyone can understand that what exactly is being transferred, or they have to do some kind of a trial and error to first receive and check the structure. So schema is nothing but a documentation of the event. It actually, you can go to the page and check that what exactly is coming on, what exactly is the data type, what exactly is the pattern and the restriction for that particular event. So it's nothing but a simplest way to understand the overall structure of the schema. The very complicated event that I have seen is of CloudTrail. It can go extremely complicated, and I'm sure that many of you will agree to that. So CloudTrail, because CloudTrail captures the whole logic, it is the ground truth. Everything happens inside the AWS. It is packing those things into the events and transmitting. So CloudTrail events are very complicated. If I want to know that what I can get from a single event, it can get really complicated. So schema and schema registry is nothing but helping the developers or to understand that what all events are being passed and what exactly the structure of those events, so they can actually code properly. Again, that is the purpose of the EventBridge, to become the enterprise or the account-wide event bus. So they assume that there will be a lot of events, and the developer need some kind of visibility that how the events look like. So schema is nothing but a structure of the event, and schema registry is nothing but the kind of a feature in which you can see all the events that the AWS has, your partner has, or even your custom application has. This is a sample of, they follow the specification, OpenAPI 3 and JSON schema, draft 4. So this is the simple structure. I am sure that it is fairly visible. So you can see the event. It has different properties: name, comment, created at. You can see the format of those different fields as well: string, array, and with item string, and then string date time. So this makes it very easy to actually understand what the actual event looks like. And for few languages, they also support bindings, so you can download the bindings and start using it. Java, right? That's the first language that comes into our mind. If it creates the classes and the other things directly, TypeScript or even Python, then it is easy to integrate and start using those things. Now, another thing is EventBridge can actually receive events from different accounts as well. You can do the cross account communication much easier. You can actually receive the events from other accounts, and you can actually send events to other accounts in other accounts event bus as well. So this is very good because it is that's how they are doing the partner SaaS partner event communication, where these predefined partners are having the understanding, they have installed the required things so that they can communicate between each other. When it comes to the asynchronous messaging concept, the dead letter queues are becoming standard. We have the dead letter queues in the Lambda, we have the dead letter queues in the SQS and SNS as well, because everything fails all the time. So if something fails, I do not want to miss my messages. I want a way so that I can recover those and replay those messages. Although replay concept in the EventBridge is slightly different now. In the last couple of weeks, they have released something, but this is the same in the same area, that if somehow my target is not able to process the event, they are down, they are throwing the error, then the retries will be managed by the EventBridge. And if the retries don't work, then the dead letter queue will actually host the messages for the letter processing. So it also has the retries and the dead letter queue concept built in, which is kind of standard. It has to be there. Vendor integration, as I mentioned, 34 vendors, even except the Salesforce, which actually does the integration via the AppFlow, which is another service of AWS. Everything else is a direct integration. We'll see a demo of that as well. And yes, the demo part. Sure. Yeah, let me know if it is still visible. So this is the dashboard of the EventBridge.
Yes, it's visible.
Dashboard of EventBridge. I'll quickly show the CloudWatch as well. We'll see there. CloudWatch. If I go to events, it will say the same thing. CloudWatch event is now Amazon EventBridge. Although I can still use this. I can still create everything. I don't have any rules, but if I create one, it will be visible here as well. So this is the EventBridge dashboard looks like. By default, if you log in now in your account, you will see this default bus for your account. I'm using the Seoul region because that's the region I have. I usually use this for the meetups and other demonstration. I have kept it clean. I don't. You won't see any clutter, but all other regions I have some kind of clutter going on. So I have kept this region clutter-free demonstration. So we will start with I have multiple demos. So we'll start with the default bus first. So this is my default bus. I'm not going to do anything. What I am interested is actually capturing all the events and doing the log. So I'm going to create a new rule. Catch all events. I'm going to do the catch all events properly. Catch all events. Event pattern. This is not a schedule, so I will use the event pattern. Predefined event patterns, and I want all the events. So this is the simple structure. If you are manually if you are just adding the custom pattern, but this is kind of doing the filtering as well. So this is the rule filtering part, where I'm just saying that I want to capture all the events which are originating from this particular account. Then comes the bus part. Because we have only one bus, it shows a very limited options. AWS default event bus. If you have in the latter demo, when we have more bus, you see the selection here. Enable the rule on the selected bus and the targets. Now, as you can see, there are fairly good number of targets as well, including API gateway, which is an interesting use case. You receive a message and you call the API gateway. You can do that. There are many other Lambda, a very popular one. But in our case, I want to keep it very simple. So what I'm going to do is I'm going to create a CloudWatch group, and what the simple thing I want is that all the events that I receive from this particular account, that should actually go to this particular CloudWatch log group. I can configure retries and everything, but I'm keeping everything default. I'm not going to transform the event as well, and I'm simply going to do the create. That's enabled. Now, immediately after that, if I go to CloudWatch and log groups, I'll see what was the name, catch all events, and all AWS events. That was the name, all AWS event. If I click on that, it has already started receiving and logging the event. So I'll see the most recent one. If I click on that, if I do US text, So as I mentioned, this is the simplest event that we have received. Again, this one has come from the AWS event, so from the Cloud Trail, and it has logged that we created a new rule. So this is, while creating this, a Cloud Trail catches everything, and we have done the same thing, that I want to catch everything and I want to just log those events. So this has started logging. This is similar to the CloudWatch. You create a new Cloud Trail and give a destination to S3. It will do the same thing. But here, we just for the understanding purpose, we have routed all the events originating from our AWS account to CloudWatch group. So that's a very simplest example of. Now we have the one rule which is operating on the default bus. So as a second, what I will do is I'll create a new bus. Super app. You can actually give the permissions, restrict, or even the organization wide. I'll keep it same. And now this creates a new event bus. So this is basically my event bus. I can use it for my application. I can actually for the internal sending out the messages and consuming these messages. Now I will create a rule which will capture this, and it will go into two separate targets. So we'll create a new rule. Super app events. Once you use it, you'll find it very simple to kind of configure and use. Plus, we are doing infrastructure as a click, which is not a right way to do it. You should either use a SAM. If you are using the serverless, you have the popular alternatives are SAM, serverless application model, which is from AWS, or you can use a serverless framework, the open source one, extremely popular. They both support EventBridge. So do write the infrastructure as a code, use the frameworks, don't create everything manually. In our case, now we are creating this rule, which is actually going to target our custom event bus. So I'm going to use the custom or the partner event bus. As a third example, we'll see the partner event bus. And I have selected my kind of a bus. Now, as a first target, I am going to use the same, that is CloudWatch log group. So my super app events. And again, nothing I'm going to configure here. I'll showcase later what we can configure. So just create. And it has the new rule, which is pointing to this bus. And for the default, we still have the catch-all. Here, my super app, I can see that. Now going to the CloudWatch log group, I can see here, there are no messages because I'm not passing anything. So I have created a simple Lambda function. Sure, it will be visible. It is using, I'm more familiar with Node.js. So it is using the Node.js SDK to actually drop a message. So whatever that we will pass into this Lambda event, it will actually just transfer that to EventBridge. So it is using the EventBridge. Interesting thing is, even if you don't have the event bus, it will still accept. It will not throw an error. So that's the event bus concept, the very standard concept, that the event bus consumes everything. If there is nothing out there, it will just ignore the message. So I am going to drop out event as this com.appgambit.mySuperApp/test event. So this is kind of a DNS based event source name. So AWS event starts with AWS dot, partner event starts with AWS partner, and custom events they actually recommend to use this kind of a formatting for not having conflicts. So this is a simple thing that I'm going to drop inside the message. I do the test. It has returned no error. So we'll come here and check, and I can see that I have a message now. So this is I sent as a message. This was my message. If I do another key 4, like 4, save and test. Come here. You can start. So this is the very simple integration. I actually created a custom event bus. I attached a rule, which is again pointing to the CloudWatch logs. And I created a Lambda function. This is already created. It's a very simple one. We just need to provide the type and the event bus name and drop the event. So I'm using the event. So whatever I pass as a payload to the Lambda, it actually transmits the entire thing to the event bridge, and that has been logged here. Now, what I want to do next is I want to actually transform and send this event to another Lambda function, which is I have created another simple Lambda functions which just does the logging, nothing other than that. So we can see the transformed event, whether it comes properly or not. So go here, edit. Again, everything is same. Keeping only thing is I'm now adding another target. So I'm fanning out. I have one target which is CloudWatch log group. I have now another target which is Lambda function. I have another Lambda function which just does the logging of the event, and I'm now going to actually create a transformer. So this is the place with what makes it very powerful. Usually in all the other cases, if you want to transform the incoming message payload, you need to do some kind of run some kind of a logic, right? And then you can get it transformed, and then you relay it to the next service in line. Here it has been provided as it is, and we can actually use it like this. So I know that I am receiving 3 keys, and this is what I want to convert into. So this is the keys that I think I know my event has, and this is what I want to transform into a simple string. Just update. So now I have 2 targets. One is Lambda function, one is log. I will invoke this again. Success. And I go to the log group. Log events, which is the Lambda functions that I have, it already has captured, and found 3 values. That's what it has printed. So I have transformed the JSON payload into a string payload, and without writing any single line of code. The receiving function is just doing the logging. It is not doing anything. That we have 10 more minutes, so I'll go into a very interesting demo. So next is what I have done is I have created an atlas. So this is cloud mongodb.com. MongoDB also has its own cloud now. Every service has their own cloud. I've created a cluster, a test cluster inside the atlas, and I have this test cluster has like few collections which are the demo collections. So what I'm going to do is I'm going to connect the weather data collection. So this data table or collection from this, I'm going to integrate this to EventBridge without kind of writing, without doing anything else, no webhooks, no pooling. So anytime I change anything here, I add, update, insert, delete, it should actually trigger a message to the partner event bus inside the EventBridge. So the steps for that fairly simple. I go to the cluster. For all the registered partner, you will see the same concept here. So again, I'll go here and I'll first come here. So there are 34 partners listed from the Salesforce, Auth0, Build Hub, ClearTap, Hexagon, Datadog as well. So I'll go to MongoDB. I'll select, go to the setup. It will give the account ID. That is my own account ID. I'll just copy that. And there it is. I will add a trigger. So this is kind of a webhook only, because MongoDB is also cloud, and now the ad hoc functions or the short-term functions or the serverless functions is different names, but underlying the same thing. You can write the code which will be executed when certain event happens. So MongoDB Cloud also has a serverless function, so you can actually write your code here. But instead of that, I want to actually transmit this to my account, not don't want to write any logic here. My region is Seoul, so I know that. I don't want to modify anything. I just want to configure this. I'll select the cluster, sorry. Database will be the weather, and the collection name is data. So this particular collection, if I insert, update, delete, or replace anything, it should actually send a message to EventBridge partner bus. See, so this is the MongoDB cloud side configurations. Now it is doing the its part. It is actually setting up the queue. Now the next question is, how do I know that it is already there? So if we come here, you will start seeing one event bus. So that is an event source. We have the MongoDB cloud has initiated to actually do the stitching part. So we'll select this and we'll associate this with an event bus. So as soon as we associate, we do not, if we want to give the permission, we can, otherwise I'm keeping it default. As soon as we do it, it immediately creates another event bus. So another event bus will start coming here. Yeah, so this is a event bus. It starts with aws.partner. So this is the prefix, so we cannot use the reserved words. So even AWS services starts with aws.service name, and partner service starts with aws.partner / the partner name. So now this is the bus that has been created. I will create a rule so that can create a rule. We can start consuming the events. Weather, data, MongoDB. Patterns, I want to consume all, so I am going to just say that all the events that I receive from this bus, my partner bus is selected. I have custom as well, but I'm selecting my partner bus because that's what I want, and I'm just going to log whatever the data that I receive from this. Not going to process anything. Create that, and now my channel is up and running. So what we'll do is we will do a little tweak here. Once you do it, you'll find it pretty simple to actually replicate. I am just doing a clone. I'm going to remove this part so that it can generate, and I'm just going to attach this one, and I'm going to do an insert. So once document has been inserted, I will come back and see if I have received any logs. I think I have. And if I say view source, and this is the document. So I have just now received a document from the MongoDB. I can see the full data as well. This has come from the partner. So it is in a less than few minutes. We can, many of the applications are hybrid. It is using the different services. Not everything is on the AWS. So if you have something like this, you can actually easily create. If you want to become a partner, there is an easiest way to actually reach out to AWS as well and become the partner as well. So that is how the integration part. In less than few minutes, we have the data coming from now MongoDB inside our AWS environment, ready to use without doing anything, without setup or creating anything specific. So going back to, I have few more minutes. So going back to the next things, quotas. So this is now very popular. Everyone who actually writes serious applications, they also go and check out what are the limits, what are the throttling limits, how, whether it's flexible or hard limits, soft limits versus hard limits. So only single thing that you see hard is the targets per row. You can have only 5 targets. So fan out is only limited to 5 services. You cannot go beyond that. Unlike the SNS where you can fan out huge number of services, but here it is only limited to 5. Other invocations, this is not a replacement of SNS. You cannot use exactly as it is for the SNS. So that's why the invocation throttling limit is also set to 2250. This is region specific. In the US East one, it will be separate. In the CL region, it is separate. This is changeable, but it is still much shorter compared to the SNS throttling limit. There is one more thing which is I have mentioned in the later slides, but latency is also different between SNS and EventBridge. So if you are writing low latency applications, you better check out the difference between two. EventBridge latency is half a second, whereas the SNS latency is still in double digit millisecond. Pricing is fairly simple. This is getting common across many of the services. You will see a very flat pricing. So EventBridge, because it's fully serverless, fully managed, they are only charging for the events $1 for 1 million messages even published and transmitted, consumed. SNS versus EventBridge, I have tables. I'll go through that only. Messaging, SQS, SNS, and EventBridge, one-to-one, one-to-many. Event type from single to multiple source. Routing, filtering is supported fully in EventBridge, partially in SNS, no in SQS. Transformation, yes, is allowed. Cross account, yes. Latency is moderate. I'll say still moderate. Half a second is it's higher latency, and throughput is also moderate compared to SNS and SQS, which has high throughput because of the kind of a service they are. Newest addition is archive and replay. This is an addition in last 10 days or so. What you can do is the events that we transmitted, if I want to archive those events and I want to, in future, I want to replay, because this is an enterprise wide bus. So whatever that you are transmitting, it is kind of some important events. Either you log it on your own by using the fan out, but that way you consume one of the targets. So now you are limited to 4 targets only. So archival and replay is added so that you can archive all the events that are being passed through the event bus, and there is no restriction. So you can actually archive infinite, and then you can replay from certain time to certain time. So if you want to found any issues fixed and you want to replay, you can do that. You want to just replay to stress test or do something on the blue-green side, you can do that. So the archival and the replay is recently added features and good one. Key takeaways. EventBridge is written on top of CloudWatch Events, so you can still use CloudWatch Events, although playing around with and using the EventBridge is kind of cooler. And it allows to consume events from AWS services 1995 plus, SaaS partners 34, custom applications like we saw, and even from the other AWS accounts. Event pass through the event buses. You write rules on top of this bus. The rules can do the filtering, that is matching the events and only take in what they want and ignore everything else, and do the transformation as well. So you can kind of change the structure of from JSON to another JSON, or from JSON to string as well. Event rules send events to popular targets like Lambda, EC2, or another AWS account. It can actually create ECS task as well. Easy to consume events from applications like Auth0, New Relic, Zendesk, MongoDB, Gusto, and PagerDuty and Datadog. So these are it. And that comes to end of my presentation. Back to you, Manoj.